Hello and welcome. My name is Matthew Frost. I am a cloud engineer by day and a Kubernetes admin by night, and I wanted to share my home lab setup and how you can do the same in your environment. So if you're getting started with Kubernetes or have had just a little bit of experience with it, this might be a good fit for you. So let's get started with this. If you have ever deployed out self hosted services like Plex or Home Assistant or really anything else, you kind of might have followed a pattern of how you deployed these services out. The easiest way to deploy out, say, Plex would be to download it onto your desktop, run a server from your desktop, and then access the Plex service by your desktop's IP address. The next level is to have a dedicated server with the server OS installed directly on hardware, installing Plex there, and then accessing Plex from that IP address of that server. The next step is to maybe containerize it, so using Docker on that server, or say using a hypervisor and deploying VMs out there that you would then install your services on, like Plex or Home Assistant, things like that. Then there's this next tier of, well, okay, I was a server admin, then a container admin, hypervisor admin. What's the next step? So I would think that maybe you want to try out Kubernetes, and that's kind of where I took the next leap in my home lab setup, is to deploy a full Kubernetes setup. There's other Kubernetes flavors like K8S or Kube Mini, but it was 2 years ago that I went for my Kubernetes CKA, Certified Kubernetes Admin, certification. And in order to get myself familiar with that, I decided to actually find a way to use it. So just learning about it or reading it out of a book is not enough for me. I need to get hands-on. I need to use it and actually rely on it on a daily or weekly basis, to keep myself fresh. So for a while I've been doing that for 2 years, and recently I've decided to revamp or reinstall everything basically from scratch. One, to replace out the hypervisor that I have right now, which is ESXi made by VMware. I would like to use Proxmox instead. Proxmox is open source, and unlike ESXi or VMware, which is bought out by Broadcom, where its future is kind of shaky, Proxmox seems to be pretty stable for its future. So that's my goal, and during this journey I have documented how I deploy out this Kubernetes cluster, and I put it out in GitHub. So if you can memorize this very long repo name, good on you. Otherwise, you just go to Milagro-Frost, and it's just that big old repo name. So this Kubernetes cluster is not just your ordinary Kubernetes cluster. I use things like Cilium for the CNI, for the networking layer, because it does not just networking, it does BGP advertisements, and it uses the gateway API for ingress application traffic flow. So traditionally it's been Nginx ingress for Kubernetes, but the cool new way is to use the gateway API, which they really do the same thing for the most part. I'm sure people would disagree with that in some way or another. So what does this environment look like? What do you expect? What should you expect out of this whenever you deploy this whole thing out? So there's a few components involved in here. You have your Kubernetes cluster, which resides in your home network. You have a router. In this case, it's a Raspberry Pi 4 running OpenWRT. And then outside of that, we're using Cloudflare for our public internet access to all of our services. So there's two flows here, two possible flows. One's an external client or an internal client. For an external client, there are DNS names that are made by the tunnel, the Cloudflare tunnels that are made for each app. So that tunnel is created and it advertises itself, creates a DNS name in Cloudflare. The traffic is proxied, meaning that whenever you resolve the DNS name for, say, home.frostbit.in, it's not going to be my home IP address, it's going to be Cloudflare's IP. And Cloudflare will get that traffic, see the DNS name, and then make the routing, the appropriate routing to get back home. There is a tunnel that is constantly connected to Cloudflare, and for all the services that reside internally. So there's no NATs involved. I don't have to do an egress NAT or an ingress NAT to make this traffic possible. All of this is done with a tunnel connection that only relies on 443 outbound to Cloudflare to establish that connection. So once the client goes to home.frostbit.in, Cloudflare sees that domain name or DNS name and will route it through Cloudflare Zero Trust, which I have set up. So since it's proxied, we can put in a little bit more logic into who can access the site or not. And I utilize Google's SSO, or there's like a couple of email addresses that are allowed to visit the site. So before they can even hit the site, they're put through a Google sign-in. So of course my email's in there, my wife's email is in there as well. So if it's authorized, then it keeps going down the tunnel here. There is a tunnel that is made as a Kubernetes resource, and that will route to the Gateway API, which is our ingress endpoint. This is where the certificate resides. It resides here. The SSL cert resides here, and as well, it resides up here as well, since this is proxy. So there's two SSL termination points. When it comes to the tunnel, it goes through port 80. It seems kind of sus, but really, if you can visit the site with HTTPS here, and then at some point it switches to HTTP to go through the tunnel. So the tunnel is encrypted, so you can kind of imagine that this is it's almost fully encrypted all the way through, almost. So it makes its HTTP routing decisions here. Says that, oh, you're trying to get to home.frostbit.in. Okay, let's take you to the service, which exposes the pod port, and then you can access the pod that way. That's the first flow. So that's coming out from the internet. So an internet client's trying to reach an internal Kubernetes application. There's a second flow, which is internal client. Now, we could have the internal client follow that same route. It would have to go out to the internet, to Cloudflare, and then it would come back home. So we call that a hairpin. So you're making a really tight turn back to basically where you already were for your final destination. I took on a little challenge here to not do that, and I was able to set up internal DNS routing with Adguard installed on OpenWRT. So what happens here is the internal client uses OpenWRT or Adguard, which is installed on OpenWRT, to resolve DNS names. Adguard has constant communication with the Kubernetes cluster, actually with external DNS resource, and any new service that gets created, if there is an annotation or a label in there that says, hey, this service actually is going to have a DNS name associated with it, it catches that and writes that DNS record into Adguard. So if this client is using this as a DNS server, then this will resolve an internal IP for that service, which is home.frostbit.in. and it will come in as 443 onto the gateway, which has a publicly trusted cert, compared to the first flow, which is over port 80, but through an encrypted tunnel. And then you know, the same effect of this. The first and second flow will have the same hops once it reaches the gateway, so which will go back to the service or the pod, and then it'll go into the pod. So yeah, there's, again, I mentioned these. We have the Cloudflare controller that sets up the tunnels for the applications. We have Cert-Manager that creates publicly trusted cert using Let's Encrypt and Cloudflare DNS authentication or verification. And then we have the external DNS for Adguard that will, again, make DNS rewrites in Adguard. So anytime it home.frostbite.in comes in, it'll catch it, capture it, have an authority for that DNS name, and then come back with a resolution for an internal IP address. So yeah, we're going to get all this done. You know, with semi-automation, most of it's automated. There's some manual steps in here. And you could automate all of this. You could make a speed run out of it, but we're going to kind of go through it step by step to kind of learn a little bit of the process. Now, if you already know a bunch about Kubernetes, you may just want to skip this video or just kind of skip through. Otherwise, if you're kind of brand new, I'm kind of more catering to you, and hopefully I don't, you know, skip a bunch of stuff. So we'll see how it goes. I've already done this video like 20 times already, more than 20 times. I keep stopping and doing it over. I don't have a script, so pardon if I'm all over the place. All right, first things first. We need a piece of hardware. We need hardware to make this work, right? I have been using a Lenovo C30 with 64 gigabytes of RAM and a 12-year-old processor for my current existing Kubernetes cluster. I'm using ESXi for my hypervisor, and I run 3 VMs with Kubernetes installed, 1 being the master and 2 are workers. Those are running on a pool of 256 gigabyte SSDs. And then there's a 4th server that is an NFS server. So, you know, your pods need persistent storage. They need a persistent volume to save their configurations even after the pod restarts. This NFS VM is going to be the backend, or is the backend storage for all of the pods that need it, and that is running on a 3 terabyte hard drive, all within the C30. What I'm going to do here is I want to transition off of ESXi, and I want to use Proxmox going forward for the hypervisor. And we could just shut the server down. All of my services will be down for that time being. You know, wipe ESXi off, put Proxmox on, and, you know, build everything back up. But I wanted things to be a little bit quicker than that. I wanted to have a faster turnaround time. Not like anybody relies on these apps and services and self-hosted things outside of myself, but, you know, I like to figure out things beforehand before I make those major changes, which is great advice for the workplace. You know, you don't want to test things in production. So I don't want to mess with this production box without knowing what the plan and process is beforehand. So this is going to be the test, the plan that I'm staging to make this transition a little easier and a little faster. So that means if I don't want to bring this server down yet, I need a second piece of hardware to kind of build everything up. And that piece of hardware is some laptop. In this case, it is a Dell M4800. This is a 11-year-old computer. But it's good for kind of a temporary Kubernetes, you know, hypervisor, or running a hypervisor with Kubernetes nodes on it. It has a 1 terabyte solid state on there, and we're going to have 3 Kubernetes nodes running under a master and 2 workers. I got 24 gigabytes of RAM, which is about double of what I need just to have the core installation of all those core functionalities of this cluster. Which means I'm not going to be able to add all of my apps on here, but I should be able to run enough to kind of know that this setup works. Rather than having an NFS server in this hypervisor like I do here, so I'm running the NFS VM on this hypervisor, I took it out of the hypervisor, and I'm actually going to be running NFS on a Raspberry Pi 4, a separate one outside of what I'm using for OpenWRT. This is just strictly serving storage over NFS, and there is a USB hard drive that's 8 terabytes connected to it. Not the best performance. I would not recommend this, but for a temporary measure, it'll work, and it could work full time. It could be fine full time. The NFS stuff is in my documentation. It is in my extracurriculars. So if you want to know more about that, that is here in the NFS backend storage. I detail that stuff. But I don't want to go over that because that's just going to make this video extremely long. All right, if there's a want, I can make a separate video for that. So first of all, for starting fresh, we don't have any of the stuff set up anywhere that I've mentioned in this diagram. We're going to go over some of the manual dependencies that you've got to go through in order to get this set up. And those are: 1, get a Cloudflare account, sign up for that. There's a free tier. I use just the free tier. Everything that I'm doing here in this diagram is all within the free tier. I don't pay for nothing in Cloudflare. And then you'll also have to sign up for Zero Trust. I don't think it automatically signs you up for Zero Trust. So yeah, on the same site, in the Cloudflare dashboard, here we go. So you sign up, and then you should be able to click on Zero Trust. And I don't know if there's a sign up process for this, but just make sure that you have access to it. Next part is setting up OpenWRT. Now this is like if you want this exact setup, you can have a different router that is BGP enabled. If you even want to use BGP, you don't have to, but you have to find some way to advertise the services that are the service resources that are being made within the cluster. Because with this setup, I have a load balancer pool that is outside of my home network. You could make the load balancer pool that will pull an IP out of in order to use it. So you need to find a way to advertise that out. And you could, say, section off a part of your home network to make that available in your load balancer pool. So like if you had a /24 of a 192.168.1.0, you can maybe carve a little bit of IP addresses out and allocate it for that load balancer pool. But in this case, I have a separate network that is outside of my home network. So my home network devices need to know how to get to it through a router, and that's what the OpenWRT BIRD or BGP, I don't know what BIRD stands for, but it's a BGP interface that you can install on OpenWRT. I don't want to go through all of this either, because I want to stay focused on the deployment of Kubernetes. But we will probably visit the router in a little bit just to verify that our BGP neighborships are working between the router and the nodes. So there's that. Proxmox, very small guide here. Proxmox is just very simple to set up. You download it, you download the ISO for Proxmox, and you write the ISO to a USB stick using Balena Etcher. This is available for Windows and Mac, as well as Linux. And then once the files are written on the USB, boot it up on whatever hardware that you want to run it on. It's going to wipe out your boot drive. And the setup is pretty easy. So you just click, 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 next, 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 yes, yes, yes. And then you should be good to go. You'll assign it in a static IP address. And whatever IP that you assigned it to, your full URL that you're going to visit is this guy here. So HTTPS your Proxmox IP 8006. So here we are. This is the stage that we're at right now. We have installed Proxmox on this laptop, this Dell M4800. We have our storage available to us. We should have a total of, this is almost a terabyte, but it's carved it out with the boot drive and then the volume. There's just one drive, but there's one volume allocated for booting Proxmox and another one for loading VMs onto. So 853 plus 100, give or take about a terabyte. So there's that. We have one NIC on this laptop, one physical NIC. There is a Wi-Fi interface, but we're not going to count that. And yeah, we have, again, we have 24 gigabytes on here. We can see, this says 100 gigabytes. Don't freak out because that's just, again, the boot volume on the drive, and currently very low CPU usage. So we're good. Proxmox is good to go. So what's next? Packer. Now, if you're not familiar with Packer, we traditionally, if you're going to deploy a VM out in Proxmox, you need to spin up a VM, download an ISO from, say, Ubuntu. So we download an Ubuntu server ISO, which contains the installation media to install Ubuntu. We boot up off the ISO. We go through and click through, install, yes, yes, okay, next, 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 install. Packer does all of that for us. Packer will download the ISO for us. It will do all the installation prompts. It'll boot it up. It will do configurations, and then it will shut it down and save it as a template inside of Proxmox. And a template is just something where you can spin other VMs off of that. So you just copy that template and then make another VM. Copy that template, make another VM. So we're going to do that 3 times to make our master and our 2 workers. And hopefully, if you try this out and you copy the code, you can maybe run this fairly easily, I hope. I mean, it doesn't always work out that way, but hopefully I've done a lot of the work for you in this Packer configuration. So some prerequisites: Packer must be installed on your local machine. I'm on a Windows machine, as you can tell. I install almost everything that I need on here, like command line tools using Chocolatey. Oops. Let's just do Choco. Oh, Chocolatey. No. There we go. The package manager, chocolatey.org. Get started, download that, install it, and then you can use you have to go in as an admin. So if you go to terminal, you right click and you run as administrator. Once Choco is installed using this software, so you download it, install it, and then Choco should be available to you. So if you wanted to install Packer, you do Choco install Packer. Ooh. Packer. And it says it's already installed. So yeah, and you have to run this PowerShell as an administrator in order for that to run correctly. But that's how I got Packer on my machine, and I'd recommend doing it that way rather than finding it online, downloading it, and following install prompts. So where were we at? There we go. So we have Packer installed on our machine. We have the repository here that we just that we downloaded. We cloned it onto our machine, and now we can run Packer. But first, we need to make sure that the variables, the things that are in our environment, are set up correctly. I need to set this up just to make it obvious. This has already been set, but it's not obvious. So we're going to say SSH pass, SSH user, packer. So here we go. So these are things that you might most likely need to change in this file right here. So the Proxmox username should stay the same. If the version numbers increase between what I'm using and what you're using, that may be different, but root@pam is the one to use. When I went through the Proxmox setup, I just gave the Proxmox server the password of password. Very secure. And then we specify the IP address here. And then you want to keep the rest of the URL the same. I gave my node the name ProxyMoxy. If you named yours something else, you got to change that. Kube version right now is at 1.30 for this setup. I think 1.3.1 is out. But as you change versions and you stray from what I've set in here, that kind of creates some unknowns and maybe come across some issues that I don't have in this setup. So keep that in mind. Whenever the template is created and it spawns that template or spawns a VM off that template, that VM is going to have a password of packer. Username packer, password packer. If you're going to change the password, you need to change the password hash. And to do that, you have to run a command that will create a hash based off of the password that you want. So I'm not going to go over that right now. Just if you want to keep it simple, just keep it like that. And you can change the password later as you spin up the VM if you want to. So what do you need to do to run this? Now that we've changed the variables for our environment, the Proxmox server is accessible and the API is already enabled by default. We don't have to go looking for that. We've changed the variables, and now we can run the Packer build. So let's do that. I'm here in VS Code, so I can easily CD to folders by just doing CD space and then dragging the folder in. And let's just copy this command. So this is downloading the ISO for Ubuntu 24.04 and verifying it with the checksum, making sure that it didn't change between now and then. And it will download the ISO, it will kick off an automated install, and then it will run Kubernetes specific configuration commands to ensure that whenever we kick off VMs off of this template, that is basically ready to become a Kubernetes node without any extra commands needed in the VM. So we've got a couple of provisioner or shell provisioners, which are just like commands that will kick off after the installs happened. Some cleanup commands, and then some networking commands. I don't know exactly why these are split up this way, because I copied this from somebody else's configuration. We're installing containerd, so we're installing a container runtime, and a couple other things. More network changes needed for the Kubernetes install. And then this section here is to install Kubernetes specific commands and programs. So yeah, this usually takes about 6 to 17 minutes, just really depends. And so for the time being, we will, so it's already spun up the VM. It's currently working on it. And we'll look at the console here. So it might come into summary, but we look at the console and we can see that it's doing stuff. Don't interact with this. Don't click in here. Don't try to type in here. Let it do its thing. And, just kind of wait it out. If you keep seeing this and you see that it's been a while and then it cancels out. This is waiting for SSH to become available. Either it didn't pick up your IP address that was assigned, that was automatically assigned through DHCP. It should be aware of what your IP is. And the only way that it knows what IP is running on this VM is if the guest agent, the QEMU, the QEMU agent is running. It's not running right now because it's in the middle of installation, but at the end it will install the agent, and then that agent should share with Proxmox what the IP is. So one, this script will collect that IP address off of this dashboard or out of the API, and then also the username and password need to match with what you've set up in the vars. So if you've changed the password here to like password, but you didn't change this, it will fail and then delete your VM. So if you don't know quite what you're doing here with the hash, I recommend just starting with Packer and then kind of make your changes in the next iteration. That would be the safest bet. Because myself, I've tried to change the password and then like not get the hash right for some reason, and it would fail. So I just keep it like that. But yeah, let's keep it on the console here, and I will just fast forward this, and we'll come back to you whenever it is finished. There we go. We have a template. If you're watching any of that stuff going on, it did ran all of our shell commands, or most of them, and it does enough to where the Kubernetes configuration happens. So if there's something that got missed, we're not missing it too terribly. All right, so we have our template. Now we can spin off our VMs off of this template. And we're done with number one. We're moving on to number two with Terraform. And Terraform will orchestrate our VM deployments in Proxmox pretty easily. So let's look at this README. And we want to open this files directory, and we want to look at our TF vars. So in here, it says prerequisites: ensure that Terraform is installed on your local machine. Again, you can use that with Chocolatey. So Choco install Terraform. I think it's on here. Yes. Oh, it must be installing a newer version. I don't want a newer one. Am I locked to some version right now? I don't think so. I'm going to cancel that. I don't want to update Terraform right now. But yeah, that's you can install Terraform that way. All right, so Proxmox server with API access. So that just means that we have Proxmox running, and we have the username and password for that server, and then SSH access to the Proxmox server. Do I need to do that? ChatGPT/GitHub Copilot wrote this, so I don't think it sometimes puts in extra stuff that I don't need. So again, set up instructions, ensure it's running, customize the TF vars as needed. So let's take a look at that. In my setup, it's the username is root@pam. That should be the same for you. Password, I set it to password. For the VM, so this is the template that we just made. It's going to be the same username and password as we set in Packer. So just if you forgot, Packer, and Packer. We set the Proxmox host IP, so this is this server. We want to set that to 250, and now we are planning out our future VMs. So we want to assign a VM for the master node, Kubernetes node. going to give that 251, and the worker nodes are down here. Let's get these let's bring these together. There we go. Now they're buddies. Now then we set IP addresses for worker IPs. So right now I'm only making 2 worker IPs. If you want to make more, then go ahead and make more. But 2's fine. You know, you're working within a virtualized environment, so it doesn't really make sense to make more unless you're just playing around. Storage pool name, for me, it's set it to local-LVM, so if you have multiples of these, just choose the one that has the LVM thin type. Subnet gateway should be the .1 of your network, what your router is, and then a /24 most likely. Node name is proxy/moxie for me, and then template name is what Packer made and set here. So this is Ubuntu 2404 LTS K8S, and that's good. So I'm going to delete these because you're not going to see these in your environment, and I've actually already deleted the VMs, so there's no reason to have the previous states saved right now. All right, let's see. No, okay. So the next part of the README is we've updated the TF-vars as needed, which we didn't have to update. We're going to initialize the Terraform, so we need to get into that directory actually. Let's say, let's call it 2A just because I don't want to have to deal with it. Navigate to the files folder in this directory. I don't need all that. Copilot. Copilot auto-completion for the win. All right, so we're going to CD to this guy. CD, oops. CD, and again, we're going to drag this folder into the terminal. And now we just do what it says here, Terraform init. I've locked, I think I'm going to keep this lock file in here, but if for some reason you want to update, oh, come on, bro. Could not retrieve list of available versions or provider proxies could not connect to registry terraform.io. Maybe that's a fluke. Let's try that again. No, not working. I'm going to rename this to .lol. Let's try this again. Hopefully it works. Kidding me. It's not working. Okay, I may have to put this on pause. Do I still have internet access? I don't have internet access. That's embarrassing. I need to check up on that. Yeah. Yeah, my internet's down. So I gotta pause this demo for now until I get this figured out. I think my ISP is not working. Alrighty. Going on pause. Alright, we're back in action. I didn't have to do anything. ISP just went down. Alright, so it wasn't the lock file, it wasn't any of that, so we're gonna put that back. And let's run it. Much better. Alright. So we did our init, and now let's do a plan to see what our automation will do. 3 to add. It's a good sign if we want to make 3 VMs. And our first VM is going to be called Kubernetes Worker 2. Our next one is Kubernetes Worker 1 and Kubernetes Master 1. So this is what I'm expecting, and we can now do a apply and actually apply the automation. Apply this configuration here. So yes, and if we look at Proximoxy, we have 3 VMs being created now. It's going to be copying the template, so you can have 2 types of clones off of templates. You can clone this template as a linked clone, so that's kind of like a delta of the VM. So it's a lot faster copy, but we're doing a full clone. We're just doing, you know, all the 1s and 0s are being copied exactly for each VM. So yeah, this will take a couple of minutes. So let's speed through that. Well, we got an issue. It's always fun. On the connection attempt failed because my laptop that I was running this on has died. No. As a matter of fact, it went to sleep. Why is it going to sleep? All right, we're going to try this again. Don't recommend running your home lab on a laptop. I have to find some way to keep it from sleeping, but it hadn't been a problem in the past, but it is now. So let's go and delete these. Actually, if we run apply, I think it can delete them for me. Okay, so yeah, if we're going to say yes to that, it's not saying it's going to destroy anything, so I don't think it's going to try and destroy these VMs, so we're going to do that ourselves. Let's go and destroy this one, 102, and then we're going to remove 103. So once that's off of there, I think we can just type yes, and as long as the laptop doesn't go to sleep, it should be peachy. All right, try this again. Alrighty, our 3 VMs are up and running. If we want to take a look at the console before we SSH into the box, so this is just like if you were sitting down at the server on a keyboard without network. Let's see here, it's still going through its stuff, so it's not totally ready. Should be able to say Packer, and we're in. All right, so we can get to the box via the console here. Can we SSH to it? So let's open up a new terminal for that. Boop. And say SSH Packer at 10.10.101.251. Now, I already had deployed this before and redeployed it, so the SSH key has changed, so we need to modify the known users. So I already have it here, .ssh, known hosts, scroll all the way down, let's delete all the Kubernetes nodes, and let's run it again. This time it doesn't know about it. We'll say yes and trust that. And we'll log in with Packer. Here we are. We're in the Kubernetes node for the master. And that's where we need to be for the next steps. So let's close out Terraform. That's done its job. And now we need to set up Kubernetes. I would highly recommend getting familiar with the Kubernetes setup and not just following these commands, because you know, it changes over different versions. If you're going to stick with 1.30 and you're not going to change anything about this, then you know it'd be okay to run this. just do the commands itself. But yeah, please read the documentation when you can. So let's make sure that our Kubernetes commands are in here. kubectls here, as well as kubeadm is here. We are on version 1305, so that's what we expect. And here we are, setup instructions on the master node. So that's where we are right now. We want to run these commands, and the first one is we're installing the Cilium command, the Cilium CLI. We're going to need this later. We're not going to need it right away, but we'll just have it there for us, ready. Now we need to initialize Kubernetes, and let's view this as the actual markdown that you're going to see. So initialize Kubernetes. Before we run this command, we need to make sure that whatever IP address that we use is going to be reflected here. And if we want to change the pod network CIDR, we can, but you don't have to. And this is not one that you access from externally or from your desktop. That's not an IP address that you would actually hit. The load balancer external IP pool is what you should be more concerned about. So you can just keep the pod network CIDR as it is, but yeah, update the advertise address though. So here in the master, we're going to copy that command, we're going to paste, hit enter, and I'm going to wait for that. Let's go ahead and SSH into the worker nodes because we're going to have to do that here right after that command completes. Let's go to the second worker. Save password. Not, this is not password. It's Packer. All right, so we're in the nodes. Still starting up. Take 4 minutes, so I guess we'll wait 4 minutes. No, we don't have to wait 4 minutes. All right, so I'll do a kubectl get pods. Now this isn't going to currently work, and that's okay, because we have to actually set up our CNI, our Cilium CNI, in order for the pods to work correctly. But for now, let's go ahead and join the workers. Oh man, I have to do this as sudo. I have to keep forgetting that. So the command that the end of this, the end of the kubeadmin will give you, it does not give you sudo, so you need to actually put sudo at the front. Let's go ahead and do the same for worker 2. So sudo and then the kubeadmin join command that we're given. All right, so all of those should be joined. And now we need to copy the kube credentials onto our home user directory. It doesn't always do this correctly when I copy it, so I'm going to do this again. Sudo chown. Let's run kubectl get pods. Nothing in the namespace. We want to look at kube system, and those are running. Okay. Yeah, it wasn't the Cilium CNI missing. It was just I didn't have the kube config installed, so I could actually authenticate to the server. All right, so that's good. Core DNS is currently pending. Maybe it's waiting for the CNI there, so we need to set that up. So on all worker nodes, we need to run the join cluster command. So we already did that. We're going back to the master, which we are now. We're going to check our nodes. So nodes will not be ready yet because the Cilium CNI network layer is not installed. We already looked at the pods for the kube system. And this is needed. We need to install the experimental gateway API, and that's not showing up here. So let's head back to initial setup and see why that's not showing up. Ah, need to tab these in. Tab. Let's go back here. Here we go. So we need to install these CRDs as well, so that our Cilium gateway will come up correctly. Get those ready for the Cilium deployment. And now we are going to install the CNI, the Cilium CNI. So we want to add the Helm repo, which should already be installed on this machine, thanks to Packer. And we need to change the service host to what the master IP is. Oops. And we've, of course, set that to 10.101.251, so this reflects my environment just fine. So I can just copy this and paste. I'm going to skip the get pods and we're going to go straight to Cilium status. I think I can do a --wait. Here we go. Let's make this a little larger. So this will give us a current status, current update on where the cluster is. Let's run that again. Where we didn't resize the window. So, okay. Let's make that really big and just kind of wait for this to have everything deploy out here. Cilium UI still trying to deploy. Let's check the pods with that command in the cube system. And UI is still container creating, so it's not errored out, not an image pool issue, it's just taking its time. Well, I don't want to sit around and wait for that. So we don't have this Hubble UI doesn't have to be ready. We can come back to that later. But let's just get a move on, and we'll come back to it if it's not done yet. So let's check the nodes again. We'll verify that the nodes are actually ready this time. Let's copy that again. Copy, paste. They are ready. So the CNI, the network layer, is good to go. And this is the load balancer IP pool that we want to apply. For me, the CIDR is 10.10.100.0/24. Either you want a network that doesn't conflict with your home network, or you allocate a portion of your home network to make that work. In this situation, I recommend that you keep the network outside of what you're using in your home network. So I haven't done an IP load balancing pool within my home network, and that may not even be possible. So, all right, so we're going to make we're going to use nano. We're going to make an lb pool.yaml. Oops, I'm used to VI. All right, so there's that. Again, I'm used to VI stuff. All right, and we're going to do a kubectl, apply F, and then add the load balancing pool. Created. So next part is setting up BGP neighborships between our Kubernetes nodes and, in my case, the OpenWRT router. So that when new services are created in Kubernetes, that the IPs used in our load balancing pool that we created are being advertised to the router, so that users on our home network know how to get to these IP address spaces. So let's see, prerequisites: Kubernetes running Cilium, we got that. A router running Bird, we got that. Router is set up with BGP peering configurations, which we did in the dependencies section that's mentioned there, and familiarity with BGP. It's not a deal breaker, but it'd be somewhat good to have knowledge of that in case when things go wrong. Before I do that, let's go and look at the router first. which we'll be doing the BGP peering with. And so we're going to SSH to root. Type in the password, and then we are going to do a bird 4CL show protocol. Bird, what is it? Bird for what? Bird CL4, Bird CL4 show protocol. So these are my existing nodes that are already out there. These are my new nodes that we created with Packer and Terraform. Currently, the neighborship is not happening. The connection is refused because the nodes are not yet participating in BGP routing. So we should see this status change whenever we apply this configuration. And paste. All right. So let's do this instead. Copy all that. Let's exit. Yes. Let's actually remove it. RMRF. Let's nano. Paste. X. Yes. Apply. Created. There we go. And what's our router say? Refused. Refused. Oh, 1's established. 2's established. And 3 is established. So now we have BGP neighborships with the router and the Kubernetes nodes. Sweet. Moving on. Let's leave the files folder open. Anything else in here? So there's troubleshooting we can do. We can look at the Cilium pods and check the routes in the pods themselves, so we can check neighborships like we did in the router, but instead we can check the neighborships on the Cilium pods. So we look at routes and peers, and we can do a TCP dump on the nodes to check if bidirectional traffic for BGP neighborships is happening. I've had to do that when I was first getting into this. So yeah, we showed the protocols on the router. And we can also show routes, which there's currently no routes on the existing nodes right now because there's no app services deployed yet. Next, we need to install the Cloudflare operator, which will help us create the tunnel between the Kubernetes cluster and Cloudflare itself. All right, so there's some, let's open this in the Markdown preview. So there's some light readings on how to get started using this Cloudflare operator provided by Adguard, this GitHub user. So thank you to him. And you want to set up in Cloudflare your token, your API token, and you want to give it specific permissions like Cloudflare tunnel edit and account settings read, and then for Frostbit IN DNS edit, because you want the tunnel to create DNS records for you for every app that you make. So first, let's see here, and we need to gather the API key. So there's a global API key as well in the Cloudflare dashboard. Again, to save time, and I know this is a huge, long video, I don't want to go through that. So, all right. So we have the token that we're going to get out of this. So it'll give you a string. When you create a token, it'll give you that string of characters and numbers, and you need to take that and you need to create a secret on your cluster that the cluster can use and the operator can use for its deployment. So that's how you will pass that key and token onto the operators using the secret. Now, you're not gonna, when you take this file, the secrets resource file, you're not gonna paste the actual secret here or the actual key. You need to encode it with base 64. So if we want to take this as an example, this is not the actual key, of course. Make sure to do this in a Linux machine because I've had issues in Windows encoding working with Linux boxes. So this is what kind of the format of an encoded string might look like. Now, I've already created the secret myself, so I'm not going to be copying this into my system here and running it. I'm going to be copying the actual cert and key. So, but for now, I'm going to pause this recording so you guys don't see that. So I made this Cloudflare.yaml, and I used this as a template. So this file here, I changed this with my base64 encoded tokens and keys. And then in here, you're going to have to update some variables to match your environment. You're going to have to get your own domain, use your own domain, update that. This can be named, this can be kept the same if you want to. And keep these here. These are just referencing the secret up here, so don't change these. This is the only place that you're going to change those values for the key and token. Set this up for your account ID. It says you'll see this account ID in your Cloudflare dashboard URL. So if you go to your dashboard for Cloudflare, you'll have a little extra stuff attached to that DNS name. So that's going to be your account ID. So update that, update the domain, the email, and this is the current version as is. So you can update that to a newer version if you want. You have to look that up. All right, so with that, we can apply kubectl apply f Cloudflare. Oh yeah, I'm getting ahead of myself here. I actually need to run this guy. Deploy the operator. Yeah, here we go. Apply that, and then let's wait for the pods to come up in the namespace first. I don't think that's a requirement, but it doesn't help to slow down a little bit, right? Dash in, and it's running, so not a long wait. Let's do kubectl apply for that Cloudflare configuration for the secrets and for the cluster tunnel setup. So let's go there. Those have been created, and we should be able to head over to our Cloudflare dashboard, and not just any dashboard, but the Zero Trust dashboard. We go to Access, and no, Networks, sorry, Tunnels, and here is our new tunnel, I believe. Not currently up. I may have to delete this one. And let's delete the configurations I have here and reapply it. I think maybe that's the issue. Let's refresh. Okay, that's better. Let's run this command. Okay, we got a tunnel ID. That's good. And it is healthy. All right. Thank you. Awesome. Confirmation that the tunnel works. We will actually use it here later on. Now, let's see here, Cert-Manager. So this is going to be the thing that will create your publicly trusted certificates using Let's Encrypt, and then using Cloudflare to validate that you own the site and that you are actually requesting a DNS name for that site. Let's view this in Markdown Preview. So prerequisites, Kubernetes cluster, obviously. and Cloudflare API key or token. I think we're going to use a token in this case. Setup instructions, read the freaking manual. Let's go ahead and add the chart for this. This specific chart, there's other Cert-Manager charts out there, but this one is specifically built for Gateway API deployments. Let's apply the CRDs. That's good. And then we're going to run this with an extra argument of enable gateway API so that the Cert-Manager is gateway aware. Check, here we go. Check pods for Cert-Manager. Currently running. So far, so good. We're going to have to create a new token. And we could use the one that we got out of the operator. I think that has the same permissions as the one that we need here, but in my case, I made a new one. And I think you can do, again, you can do it either way. All right, so we save the API token in a secret, and let's do that. I think I have that saved somewhere, so give me a moment. All right, I'm back. So I realized I have a example YAML file here that will create the secret and will create the issuer as described in the documentation here. So this mentions doing it this way, but actually in the example we're creating the secret using a YAML file rather than a command line. And again, this needs to be the token, but base 64 encoded. And then you need to change some values in here for yourself, like the email. Keep this the way it is. Do not change that. And because this is just this is a secret that the issuer will use and create itself rather than you making it for it. And this is the secret being referenced up here. So yeah, I have a Cert-Manager.yaml myself with my own personal credentials and information. So I'm going to go ahead and apply that now. Those have been created, and are there some validation scripts I can run off of this? Oops. V. No. Just going to have to trust the system. Alrighty, let's move on. We'll be able to test this Cert-Manager once we create our first pod deployment, our first application in there. On to Adguard. So again, Adguard is running on my OpenWRT router. I installed it as an additional package. And Adguard is like Pi-hole, if you've heard of that. It can filter out spammy or kind of malicious DNS names that are requested. So if, or like adult sites. So if any of those requests come across it, it can block them or redirect you somewhere else. This setup uses that kind of that redirection, or what they call DNS rewrite capabilities, to take in a DNS name and provide back an IP address without being an actual DNS authoritative server. So it's kind of a little bit of a hack. Alrighty, so prerequisites, a cluster, obviously. Adguard installed and running somewhere in your network. In this case, I'm running it on OpenWRT on a Raspberry. So let's do kind of the same that we did with the Cert-Manager by installing this feature with Helm. Oh, get me back into the preview. Here we go. Copy, pasty. And then let's see. And this is where I begin muting my mic all the way through the rest of this recording. So I'm going to be doing a bit of an overlay of the video with audio that was captured afterwards. So yeah, good times. So this time we're going to create the password using a command line rather than a YAML file. That is going to be this command in the Adguard DNS secret.sh. We want to copy this command. We want to change some values, and one being the router IP as well as the password in that command. So whatever password you've given Adguard, change it to that password, and change the IP in this command to what your Adguard instance is listening on. And root should be the username regardless, unless you want to use a different user, but root is default. So we would copy that, and then we would paste that into the terminal there to apply the secret for that configuration. Next is copying the Adguard Helm values. So this is actually a command that is writing all those values to a file called External-DNS Adguard values.yaml. We'll run the Helm command that is in the README and go ahead and get that going. There is a warning in here, but that's something that we can ignore for now. So that is the Adguard deployment. And then we can check the pods that were created off of that Helm chart. And it looks like we have running pods for external DNS Adguard. So that looks good to go. So again, we did Adguard DNS, we did Cert-Manager deployment, Cloudflare operator, Cilium BGP, and the initial setup. So as for the core Kubernetes configurations, this is good to go. Which should now bring us into the Zero Trust configuration. So we are going to be configuring Cloudflare using Terraform, not just Cloudflare, but the Cloudflare Zero Trust, the mechanism that will allow certain users access to your sites using Google email addresses. So here in the README, we have some prerequisites: have a Cloudflare account, buy a domain to manage and sign up for Zero Trust, and then all sites that tunnel through Cloudflare must be proxied through Cloudflare in order for Zero Trust to kick in. When you're looking at the DNS record, you should have an orange cloud next to it to indicate that it's being proxied. Setup instructions, read the manual, and we need to create a new token for Terraform to use so that it can modify Zero Trust policies and other things like that. So this here is the permissions needed when you're making a token: access to organizations, identity providers, groups, edit. And this is going to be a different token than what you are using for the Cert-Manager or the Cloudflare operator for tunnels, because it's going to require a different set of permissions than the other two deployments. So yeah, get those set up in your dashboard and your profile settings, and output the token. Let's see. I have actually already deployed out this zero trust with Terraform, so I don't want to run it again, but we'll kind of do a couple of commands to show that it has been deployed already. So for you, if you're just downloading this and trying it out, you need to move the Terraform examples, TFVars examples to TFVars. So this is the example file. Again, rename this to terraform.tfvars and then update your values. Get your account ID. You've already done that before in the Cloud Operator deployment. When you make the API token, of course, you're going to have an output of that. This is going to be the clear text, not base 64 encoded value, and then your zone, which is going to be the DNS name where all of your sites are going to land on, or hosting all of them in. And then for allowed emails, you need to follow this structure when adding new emails. So you need to have an email block, then the email equals the email address, and then if you want a new one, just add another block. So both me and Joe Mama are going to have access to these sites whenever we deploy this zero trust out. So now that we updated these variables, let's go ahead and do a Terraform init and a Terraform plan. So let's go ahead and do this. We're going to cd to the directory where these Terraform files are. So we just do a cd space and then drag the folder where these files are into the VS Code terminal, like so. And then I'm not going to do a Terraform init because I've already done that and also done an apply previously, but let's kind of see what the output would look like. And it looks like there's some changes that need to be made. I didn't end up applying these. I didn't want to change the environment. I might have done something manually. So I didn't want to disturb that. But the configurations that are in here should work for you and create that white list of email addresses. So let's take a look at the dashboard now. We'll look at the zero trust policies that have been created, and that's going to be within the Access Application section. The one that we created is called Default Application. And yep, we are filtering for frostbit.in, type self-hosted, and we have one policy applied, and it's the default policy that's been created by Terraform as well. Let's go and edit and click on the policy, and let's take a look here. So we are including one group of emails, and for some reason that doesn't load all the time, the value. So if we go in and click edit, there we go. And here, our default group is made. If we click on that, I don't think we are, but inside of there are the two email addresses that we set up in Terraform, Milagro Frost and Joe Mama. So yeah, that is the Terraform deployment of Zero Trust. And here's the main event. We are going to deploy our first application using all of the core services that we just deployed. The Cert-Manager, the tunnels, the gateways, all that stuff. We're going to utilize all that and then put it to the test to make sure that all of those things work. And we have a pod that we're just going to deploy our pod and services, our pod and pod service. We're going to have an ingress that deploys the gateway and HTTP route, and then a tunnel that will create the tunnel into our application from out in the internet from Cloudflare. The pod is going to test whether or not our load balancer pool is working correctly when the service is created with the pod, as well as seeing if the BGP service advertisements are working correctly, because when that service is created, that should advertise out to OpenWRT that, hey, I have a new IP address that I want to share with you. We should see that show up in the table, and then we should be able to access the pod from the cluster, or that the pod from the cluster is working properly. So can we hit the service, the service resource from, say, our desktop? So we are going to cd again to this different directory, and in here we have a few files, and actually, I don't want to apply it here because that will apply to my existing cluster. I need to take the contents of this file and paste it into my SSH session that I have over here on the left. So copy all that, let's make a new file with nano pod.yaml and enter, paste that there. We are going to save it like we will, like we're in a nano, and then we're going to apply it. And oh, looks like we have an issue. Let's go take a look at the pod file and see what might have gone wrong there. It says at line 3 there's an issue. Oh, it looks like I had an I at the very top of this file that I need to get rid of. Again, I'm used to V or VI, where you need to insert an I to start inserting. But there we go. Pod's creating, pod is running, and the service is running as well. We can see that it has an IP address from the load balancer pool of 10.10.100.0, and it's listening on port 80. So let's take a look here and see if we can access it. Yes, we can access that service from our desktop. So that means a couple of things. One, the CNI is working, the pod networking layer is working, and then that IP address is being advertised to the router, because otherwise my home network wouldn't know how to get to that IP address. So we're going to open up our OpenWRT SSH session, and we are going to show routes and grep for 10.100.0. And yes, we can see that we do have a new IP in here. And actually there's more to that route. It's not just one node advertising that, it should be all three. Yeah, all three are advertising that they know how to get to that IP address. So yeah, my desktop will reach out to the router and ask the router, hey, how do I get to this? And the router knows exactly where to go because of the BGP advertisements between itself and the nodes. Up next is the ingress stuff, like the HTTP route and the gateway. And actually, while we're here, I want to stop that real quick. Now, when I deployed this code here, I made a mistake. With the ingress, there's a gateway and an HTTP route that we're deploying in this file. I made a mistake on line 42 here. My parent ref is saying gateway-home. It should just be gateway. I've changed this in the documentation already, but I spent a long time trying to figure out why that wasn't working, and ends up it was just because of that. So just a little foreshadowing there, a little bit of an explanation, and let's just keep going. So let's copy the incorrect contents. I didn't know at the time, but we're going to copy those contents and make a new file called ingress nano space ingress.yaml. We're going to paste that in, save it, and apply. kubectl apply -f ingress.yaml. The gateway and route have now been created. So what are we going to check for here? In the README, it's going to explain why this is a success. We're going to check out the gateway. It's been programmed. It's true. And the HTTP route. Actually, let's check the statuses. So we can check a more detailed status of the gateway. So we're looking at it, and listeners, it is true, true, status true, status true, status true, status true, status false, because this is a condition for the HTTPS listener, which currently the certificate is not working. And I'm going to look up the order command to see where the how the public certificate provisioning is working at the moment. So I'm going to copy this from my existing cluster and I'm going to paste it into here. And right now this is currently pending. Now what past Matt doesn't know right now is that the API key and token were formatted incorrectly whenever I generated the secret. So throughout this process, I'm looking at see if the DNS name has been created. That it's not the exact DNS name, but it's kind of a DNS name to let Let's Encrypt know that I know this, I own this site. Here's a DNS name that you're looking for in order for you to generate the cert for me, but that's not being created in my DNS. So, and again, it's not being created in Cloudflare. It's not, the verification process is not happening because the Cert-Manager controller doesn't have the correct token secret or API secret. So let's skip forward to where I find that out real quick. One of the things I did is to troubleshoot is I ended up looking at the pods in the Cert-Manager namespace, and I looked at this specific pod called Cert-Manager, and I could see that it says the Cloudflare API token is invalid. Not invalid, but invalid. So that's how I then discovered, okay, the secret that I put out there for this Cloudflare, for the Cert-Manager was incorrect. So I need to fix the secret, whether that secret had bad encoding on it whenever I uploaded it with the YAML file. What I ended up doing was, instead of using the YAML file to create the secret, this actually using ChatGPT here, we could see that it assessed my logs and said that it didn't like the format of the secret. So instead of using, again, the YAML file to create the secret, I ended up using a command line to do it instead. So with the command line, you can just use the token in its plain text state rather than encoding it. So I got rid of that secret method here and used the command to create that. And once I updated the cert and restarted the Cert-Manager pods, then I wasn't getting any more token errors. So once I restarted the pods, I could see that I wasn't getting any more invalid logs. I ran my command here to check the certificate ordering status. It's now valid. The order is valid. The certificate request is approved. It's ready. And now my secret is also ready as well to be used for SSL termination on the Gateway API. Now, part of the Gateway API deployment with the HTTP route is that when that's created, then that should also kick off a DNS entry to be inserted in Adguard. So we're going to log in here with root on Adguard, and we're going to navigate to the filters, custom filtering rules, and we are going to search for home 1, which this site that we set up is named, its DNS name. And there we go, home 1 with the IP address of 10.10.100.1. So that means that our external DNS controller is working, it's communicating with Adguard, and internal clients know how to resolve home1.frostbit.in. You need to make sure that in order to utilize that internal resolution that we are using an internal DNS server, the Adguard one specifically. So Adguard is on 10.10.100.1. So now we should be resolving home1 internally. Bada boom. Site works internally and on HTTPS and HTTP. So yeah, that's pretty cool. And we will be moving on to the tunnel deployment so that we can actually access this site externally with an external DNS name. We're going to go ahead and switch back to an external DNS so that when we resolve the site next time, that it is going to be pulled from Cloudflare rather than from Adguard. And we'll do a little test here. Now that we are using Google DNS, we should now refresh this site, and it should not work because there's actually not a public DNS record. There's an internal one, but not a public one. So we can fix that using the tunnel resource, the tunnel binding resource that will give us our Cloudflare tunnel connection from between us and Cloudflare itself. So some important values here. One is the FQDN. So this is the DNS name that's going to get made in Cloudflare. You need to set a target to ensure that when it comes in for home 1, that it will get routed to the HTTP endpoint for our gateway. In this case, that is the service name. The service name is called Cilium Gateway on the default namespace on port 80. Now, we can't do 443 because the Gateway API does not yet support SSL termination and re-termination. So it can't listen on 443 and then have a 443 connection with the backend yet. But I think it's coming down the pipe eventually. So yeah, let's go ahead and create the tunnel. Let's copy those contents from our VS Code, paste it into Nano, save this, right? Everything looks good there. Save, and then we will apply. Don't forget the -F. And we will take a look and see if the resource has been made. Scroll down a little bit. Get tunnel binding. Yep, so there's a tunnel, and there's the FQDNs that are associated with it. And now at this point, I was going to test the site and was getting a 404 because ends up my gateway and HTTP route were not working as expected because again, the parent ref and the HTTP route resource had the wrong name of the gateway. It was gateway-home when it should have just been gateway. But all of that has been fixed in the current documentation, and you shouldn't be experiencing that kind of issue. The DNS name is in my zone, so home 1 is there and that is resolving to the tunnel ID. It is proxied, got that orange cloud there, meaning that we will be using zero trust with this site. And let's go fast forward to this where I found the mistake in the gateway and HTTP route configurations and fix that rather than watching me look everywhere else besides that. So if you're watching the time jumped from 11:29 to 12:08. So I spent 30 minutes focusing on the tunnel, but now I'm over here checking HTTP route statuses. So the gateway looked good. Now let's check out the route. Wanted to check and see if I should be seeing host names when I'm looking at the status there, and no, don't need to have host names showing up there to show that it is working or not. But then I'm like, oh, what's this? Status conditions gateway-home not found. Huh, that's weird. Well, what's the name of my gateway? Was it gateway-home or was it called gateway? I think I was cussing a lot right here. Good thing it's been muted the whole time. All right, so we're looking at the ingress. What's the gateway called? The gateway is called gateway, not gateway-home. We scroll down to the HTTP route. Line 42, gateway-home. Delete that. All right, we found the fix. Let's just go ahead and reapply with the correct configurations. Let's remove the old ingress.yaml. Let's make a new one. Paste, save, yes, and then apply. configured. And are we going to check the HTTP route? Check its conditions, check its status, and everything is happy. So if you see, you still see the error there, gateway home does not exist, but that's the first generation. We want to look at the second conditions section, generation 2. Everything has been accepted, every status is true. That's a very good thing. I wanted to check the service. The service IP did not change. If we refresh, that site is good. For some reason, maybe the site was cached and that's why I got a good status last time. But I am just pounding the crap out of the F5 key just to make sure that, you know, Chrome's not caching anything or anything like that. So at this point, we should be able to test the Cloudflare DNS name. So we're already using the external DNS server or the Google DNS server. So I think at this point we're going to have a successful test all the way around. Yep, still using external. I guess I wanted to try internally first. Home.frost. Oh, I can't. There we go. So yeah, that works. Refresh, 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 refresh. And this site still works. Okay. So let's move on to testing the site externally. And there we go. It works, baby. That was a lot of tears for 30 minutes, but so glad that this works now. And, you know, just when you're creating gateways and HTTP routes, double check your references in the HTTP route for the gateway name, because that's going to cause issues. It's going to give you a 404. It's not very descriptive when you're trying to visit from a browser. You can set up advanced, or you can set up debugging logs on the Envoy Cilium pods. You have to edit the deployment of those pods with kubectl and edit the container configurations, but you know that's outside the scope of this video. I don't go through that in this recording, but yeah, it's when you're adding complexity, expect complex issues with simple solutions. I think I was talking a lot more in here. I don't remember what I was saying, but going through this installation twice now, I came across issues each time. So if you come across issues, please let me know. Create an issue on my GitHub repository to start any kind of communication with me. Hopefully I'll be able to get to you as soon as possible, because one, I'd like to have proper and correct documentation, and there might have been things that I did that I assumed that I had written down, but I actually did not, or other things like that. So help me out here, help everyone else out that might want to use this repository to test and play with you know, these kind of tools and core functionalities. But yeah, I thank you for watching, and thank you for working with me in these technical difficulties. And if you are looking for any more information about how some of this stuff is set up, or you want additional videos for further explanations, you know, just let me know. And I will see you next time. Bye-bye.